Okay, so let's go ahead and take a look at all the odd numbered questions. So with a 45, 45, 90 degree triangle, remember that this is the root 2 side. So if I take this, my x and my y are going to be the same, and it's going to be equal to this is the same thing as x root 2. So if I solve that equation, I'm going to erase this for a second. So if I go 4 is equal to x root 2, then x is going to be equal to 4 over root 2, which when I rationalize my denominator, I get x is equal to 4 root 2 over 2. Those can reduce, so I get x is equal to 2 root 2. And because it's an isosceles triangle, they are the same. So x and y are both going to be equal to 2 root 2. Okay, so now question 3. This 6 is going to be equal to x root 2. So then again, if x is equal to 6 over root 2, because I can divide both sides here by root 2, rationalize my denominator. So I get 6 root 2 over 2. Oops. And then my 6 and my 2 reduce to this as x is equal to 3 root 2. Because it's an isosceles triangle, then x and y are both equal to each other. So they're both equal to 3 root 2. Okay, so again, this is going to be equal to x root 2. So if x root 2 is equal to 2 root 6, then when I divide both sides by root 2, I get x is equal to 2 root 6 over root 2. Rationalize my denominator. So I get x is equal to 2 root 12 over 2. My 2's cancel out, so I'm left with x is equal to root 12. Root 12 is the same thing as root 4 times root 3, so x is equal to 2 root 3. And both x and y are the same because it's an isosceles triangle. Oops. So they're both equal to 2 root 3. Okay. 30, 60, 90 triangle. So this is equal to 2x. So x is on the 60 degree side. So this is equal to 5. So y is equal to 5, which means that x is equal to 5 root 3. Okay. And then 9, I'm going to find sine, cosine, and tangent. I don't want you to do it for both angle measurements. You just have to do it for one. That's fine. So Pythagorean theorem says 6 squared plus b squared is equal to 9 squared. So 36 plus b squared is equal to 81. Subtract 36 from both sides. So b squared is equal to 45. And then, so then b is equal to the square root of 45. So b is equal to root 9 times root 5. So b is equal to 3 root 5. So now I want sine, let's go with angle v, right? So I want sine of v, cosine of v, tangent of v. Then I want cosecant of v, secant of v, and cotangent of v. And I'm hoping that by now that we're getting into a review assignment that you guys can rationalize the denominator sort of in your head. So we're going to do sine, which is 3 root 5 over 9. So then this is 9 over 3 root 5, which is going to be 9 root 5 over 15. So notice I took my 9 over 3 root 5, multiplied the top and bottom by root 5. So I got 9 root 5 and then a 3 times 5. So that's how I got my 15 in my denominator. And then cosine is 6 over 9, which is going to be 2 over 3. So then secant is 3 halves. And then tangent of v is going to be 3 root 5 over 6, which is root 5 over 2. So then cotangent will be 2 over root 5, which is 2 root 5 over 5. Skipping 10, going to 11. So trig ratios of 210 degrees. So 210 degrees is in quadrant 3. My reference angle is 210 minus 180 degrees. So I get 30 degrees for my reference angle. My triangle says root 3, 1, and 2. Okay, so now I want to find sine of 210, cosine of 210, tangent of 210, and then I want to find cosecant of 210, secant of 210, and then cotangent of 210. Okay, and now what I have is, because 210 is in quadrant 3, only tangent and cotangent are positive. So then everybody else is negative. So sine is negative, cosecant, secant, and cosine are negative. Everybody else is positive. I put my negative signs first. Now I'm going to do a 30 degrees. So sine of 30 is 1/2. So that gives me 2 over 1. Root 3 over 2 is my cosine. So then 2 over root 3 is my secant. So this is negative 2 root 3 over 3 when I rationalize my denominator. Tangent will be 1 over root 3, which is the same thing as root 3 over 3. And then cotangent will be root 3 over 1. Okay, so that's all 6 trig functions of 210 degrees. Remember, with negative 210, I know this is an even one, but make sure that you turn it into a positive angle first before you do it. Okay, so then 135 degrees, so 135 is in quadrant 2, so that means that sine and cosecant are positive and everybody else is negative. I have a 45, 45, 90 triangle. My reference angle is going to be 180 minus 135, so that's how I knew it was 45. So 45, 45, 91, 1 root 2. So I have sine of 135, cosine of 135, tangent of 135, cosecant of 135, secant of 135, and cotangent of 135. And so now sine and cosecant are positive. Everybody else is negative. So then I get a root 2 over 2, a root 2 over 1, and then tangent is 1, so is cotangent. Okay. With this whole cosine business, it would have been 1 over root 2, but then when I rationalize the denominator, right, I get root 2 over 2.